Okay, hello everybody. My name is Jamie Coleman. I'm a software engineer and developer advocate for IBM. And today I'm going to talk to you about my favorite open source stack, which consists of OpenShift, OpenLiberty, OpenJ9, and MicroProfile. So just to start off a bit about me, I'm a developer advocate. I've mainly spent my career doing work around microservices and containers. I did a bit of work on the testing infrastructure for ZOS and mainframe, so modernizing that and changing that to Java. And then basically I worked on the container team for WebSphere, and then I've worked with OpenLiberty, and now here I am as an advocate. So let's get started. Okay, so a bit of an overview of what we're going to talk about today. First of all, I'm going to give you some random facts about the cloud. And I'll tie these into the stack later on, so it may seem a bit random at the beginning. And then a bit about open source's history. Then I'm going to talk about MicroProfile and a bit about the different specs. And then I'm going to give you a quick demo of an open source environment we're using for education. And I'm going to show you about Microshed testing there, which is a great way to use containers to kind of replicate your production environment. Then I'm going to talk about OpenLiberty and how that compares to some of the other Java application servers out there. Then we'll talk a bit about OpenJ9 and a bit about some of the tweaks you can do to the JVM to make it perform even faster than it already does. And then I'm actually going to show you one of those tweaks to prove to you the difference it makes just playing around with some of the arguments you can give OpenJ9. And then just to tie it all together, I'll talk a bit about OpenShift and then do a bit of a recap. Okay, so like I said, I'm going to show you some random facts about cloud data centers. Hopefully this should be interesting to everybody. So yeah, so there's over 7,500 major data centers. And when I say major, these are the big ones. And the Natural Resource Defense Council currently estimates that data centers consume 1/3 of all global electricity consumption. So to think about that, put that into perspective, if you think about data, the internet traffic every hour fills 7 million DVDs. So that's enough to scale Mount Everest 95 times, and that's per hour. So there's over 500,000 data centers in the world, and this includes all the little ones too. So like the ones we have, for example, for testing and development in where I work. So there's a lot of data centers out there, and these things are all invisible, well, most of them, but they're consuming a lot of electricity. So currently, by 2021, experts believe that 1/3 of all data will pass through the cloud. We currently produce about 1.2 trillion gigabytes of data, and in the next few years, if we're not careful, data centers will start using 1/5 of the whole world's energy supply. So you've got cities like New York, Beijing, Vegas, Hong Kong, lit up like Christmas trees, but yet these invisible things on the clouds, that's hosting the clouds that we can't see, are going to be consuming a lot of our planet's energy. So why would you care about saving energy? Well, I'd hope most people listening to this talk would want to save electricity. But if you think about all you get told at talks or at conferences is about saving money on the cloud. Which is, okay, as a developer, you'll get kudos if you save your organization a bit of money, but it won't make like massive differences to your life. Whereas if you start thinking about it as energy, whereas data centers, once they're set up and they've bought the infrastructure, most of their cost is electricity at the end of the day. So by saving money on the cloud, you're kind of indirectly saving electricity as well. And just by moving to the cloud, you're doing the same thing. So, for example, this is your data center locally, and you have to have the capacity to deal with peak load all the time. So you have to have those resources there ready. Then if you move, say, for example, your monolith to the cloud, you're already freeing up resources for other people to use. So not only are you saving money, but you're also going to be saving energy and allowing other people to use the resources you're not. And then if you turn to microservices, you have more like granular kind of control over your services, and they're a lot smaller. And having the ability to scale very quickly up and down will again save you money on the cloud and save you energy. And it also frees up resources for other people to use on the cloud. So everyone kind of knows what microservices, and again, just for anyone on here that doesn't, essentially having single services that do specific tasks This kind of allows you to break apart your application into lots of smaller services, which you can then scale individually depending on the load. It also allows teams to work, like agile teams, to work on individual services. And yeah, it just basically makes, for example, deploying updates or making changes a lot easier. And then you can do that without having to take down the whole of your application. So a bit of a history of open source. Open source has a very long history, and this is only a small fraction of that. And I've tried to map out some of the big things I see have kind of made a difference or have made a big impact in the open source community. So, for example, the A2 system in 1953 was the kind of first example I could see of a commercial open source system. Essentially, the company shipped its source code with its product and asked for feedback. A little bit different to GitHub issues, because back then I suppose they would have had to write it on pieces of paper, put it in the post, so a lot more longer process. But this is kind of the first example of this happening. And then you've got stuff like Linux kernel and Debian, obviously big projects, the first open source operating system. And then OpenJDK, so open sourcing Java, giving it to the open source community. And then something more recent, which I think has had a massive impact over the last 12 years, is GitHub. So having a platform where everyone knows how to use it, you can freely put your source code on there. It's got ways to, create issues, space to review codes. It's got management of pull requests and security. Having this big platform that everybody knows how to use, I think has had a massive impact on open source projects. And then I can't not mention Android. Definitely, in my opinion, one of the most successful open source projects in the world. Used on, I think billions of devices around the world. Every manufacturer has their own flavor for it, so they've tweaked it. So yeah, definitely a testament to how far open source has come. So general benefits of open source: study, copy, modify, redistribute. But then you also have things like privacy and security. So having a big community around the world and having lots of different eyes look at your code will definitely help you find bugs a lot quicker. Again, you have low or no cost, so software is free generally with open source. And then when you get to the point where you want to shout at someone about something, you have the ability to have optional licensing with most projects. And then with such a big community, especially if they're global, it can increase quality, collaboration, and efficiency. So for essentially, generally a product will be worked on in a specific location by a specific team, but having people with different mindsets from around the world, looking at code, looking at it in different ways, having different experiences, and having their say and their inputs will definitely make the product a lot better. Organizations can have a particular view on a way things should be done, and unless they're challenged or given a good reason why you shouldn't do it that way or possibly do it in a different way, it may go down a very single route. Whereas having a collaboration with lots of different organizations and people helps broaden that. So let's talk a bit about Eclipse MicroProfile. So what is Eclipse MicroProfile? Eclipse MicroProfile is an open source community specification for enterprise Java. Essentially Java EE, which is now Jakarta EE, it was going a bit slow or not quite in the right direction in regards to cloud native Java. And at this point, the cloud had already been a thing for a few years. So a community of individuals and organizations kind of got together to create Eclipse MicroProfile to bring microservices to the enterprise Java community. So these are some of the contributors, and without many of these, the project would not be where it is today. Loads of different contributors, more than 140 now, and a lot of them are part of Java user groups, and Java user groups talk about MicroProfile, and loads of different vendors, and loads of different implementations too. So I'm not stalking anyone. This information was freely available, but I kind of tried to map out where some of the community is for MicroProfile. And as you can see, it's got a nice, good spread across the whole globe, which is cool. And there's loads of ways to get involved. So you can go Google Groups, MicroProfile projects, and they also have bi-weekly and quarterly community meetings. You've got the YouTube channel, or you can go to the video hangout. And again, these are all the different vendors and implementations. So the great thing about MicroProfile is it is vendor neutral. You can go to lots of different vendors to get support for this. So that is one of the great things about MicroProfile. So this is kind of the MicroProfile 3.3 stack. And the bottom layer is kind of what we thought would be the basis of what we need for microservices in Java. Then we've got the second level, which is kind of to make basically our applications, our microservices more robust. And then the top level is to kind of, do debugging, tracing, kind of figure out what's going on once they're deployed. So JAX-RS, again, very simple. You've just got your app path annotation. It produces and consumes JSON. And then essentially, you've got a post request, and that's pretty much all that's required. REST client, so attaching to a REST endpoint. Again, the only difference here is the register REST client. CDI, context dependency injection, quite a big topic, so I'm not going to go into too much about what that is, but essentially allows you to manage the life cycle of some of your Java objects. And as you see here, we've just easily injected a Java object copy shop into our class. JSONB is essentially a way to turn like a Java bean or a data class into essentially JSON, and then have the other microservice on the other end instantly turn that back into a data class or a Java bean. And very easy to do. And you just do consumes and you can just output it, and JSONB will do all the conversion yourself. So you just basically change the response type to a specific kind of object. And JSONP is essentially a parser. So you can go through your JSON and pull out specific little bits of information that you require. OpenAPI, so we need a way to document our APIs, our endpoints. So this is based on Swagger. For example, when you enable the OpenAPI feature in OpenLiberty, it automatically gives you a nice front end with the ability to test all your different endpoints. And what you can do, you can edit the JSON, see different response codes, and do all kinds of things. And this is definitely required when you're working with lots of different teams when they're all working on different microservices, because it will help the other teams understand exactly what those endpoints do. JWT, so JSON Web Tokens. So now we've got these different services talking to each other rather than one application. All this information is going over a network, essentially. So we thought about different ways to do it, and JWT, which works really well with HTTP, was a good solution to this. And it's very simple. You can just add @roles_allowed on top of your methods, which will check the JWT token in your HTTP header to make sure it has the right permissions. If it doesn't, then they will get a permission error. Default tolerance is quite cool. This is kind of based on something Netflix did quite a while ago, but essentially it basically will allow you to, if you have a problem, so here we've got a timeout exception. We don't show it here, but what you can do is then go and tell essentially that microservice to go and use a different method. It'll then go and call a different method, which could, for example, use an old microservice to configure as a backup. So it's really good for stuff like that. Configuration, so config essentially allows you to pretty much externalize your configuration. You don't want essentially configuration inside your microservice. That's going to get very messy when you've got thousands of microservices all in like different environments. So externalizing that is great. And with OpenLiberty, it can dynamically know that you've changed the configuration, which is cool. Health kind of is what it says on the tin. Pretty much it checks the health of your endpoint just to make sure it's ready to receive requests. Metrics. So metrics is quite cool. So the general metrics will give you JVM data. It'll give you some information in regards to your memory footprint and how much CPU usage you're using. But you can also do custom metrics. So for example, here we are getting some custom metrics on the amount of orders made in our coffee shop application. Open tracing, so basically it just allows us to trace all these requests that go in between all these microservices. JAX-RS methods are automatically traced by default, but you can have custom tracing, so just by adding @trace to a method, it will automatically retrace any requests from that method. So what about containers and Kubernetes? So we're not going to talk about Istio today, but we are going to talk about containers and Kubernetes and MicroProfile. So for example, what you can do with Kubernetes is you can create config maps. And you can do this by just using the kubectl create command, or you can create the config maps in your YAML. And essentially what this allows you to do is inject config from those config maps into your microservice. And with health, basically we can just essentially use the health endpoints from our application and use that with Kubernetes. So Kubernetes can check that with the readiness probe to see if it's ready to serve requests, and then when it is, then obviously it'll start diverting traffic to that microservice. So can't talk about all this and not talk about test containers, and I'm going to give you a little demo about this in a moment. Essentially, test containers are a way to pretty much try and replicate a production containerized environment locally on your user's machine. So it's got lots of different implementations, and this is really, really good for testing, essentially trying to test your environment. So here's an example of a microshed test with MicroProfile. So quite simply, at the top of the class, we have @microshed tests. That'll tell Maven that it's essentially a microshed test when it's going to run, do its testing phase. And the good thing about microshed testing, it goes into your testing phase of your build. So you don't have to do anything special with Maven. It just knows that your microshed test is a part of your testing phase. Then we have the container. And that essentially is a container your application is running in. Here we specified the context route. You can specify stuff like ports, etc. And then simply we inject our REST client, and then we have @test, just the test as you normally would. So again, this is a really, really good way to try and replicate your production environment as much as possible on your local machine. You can use your own images. So if you specify a Docker file, it can do a Docker build for you. It's entirely up to you. So yeah, so we've got these standalone projects that work really, really well, essentially with MicroProfile. So microshed testing is good. We've also got reactive streams, operators, and reactive messaging, which I definitely would recommend to check out because reactive is a really good architecture style. So I'm going to give you a quick demo of the environment. Please have a look and note down that URL. That URL will essentially allow you to follow on and do this at home. So what this environment is essentially it's pretty much a development environment, but through a browser. So you've got your IDE, which is kind of based on VS Code. You've got your terminal with Maven, your JVM. You've got instructions on the left to follow along and kind of follow along with any of the work you need to do. And it's got OpenShift, Docker, Kubernetes, everything you kind of need. So I hope you've all looked at that URL and you've noted that down if you do want to follow along. And then we're going to go to here. So I'm just going to use this. Yeah, here we go. So this is module 3. So again, we're going to have a quick look at microshed testing. So just wait for this to load up. So this environment is all running in containers, which is really, really cool. I hope you can all see everything okay. So yeah, this is all running containers. So like I mentioned, you've got your terminal down here with everything you need, all your tools, and we're just going to get started. So I'm going to quickly go and clone down this repository, and then I'm going to quickly go into the finished directory and just verify everything works, and then this will also populate my Maven cache. So back to the environment. So these environments are really cool, and honestly, I think in the future, this is where developer environments will end up. Probably not for a while, but I can see this definitely becoming more mainstream. And essentially, in the projects folder that we cloned down the repo, it's given us essentially the project here. So we're just going through the finished directory to just essentially spin everything up. But if we go to the start directory, we can, for example, see your POM and all kinds of cool stuff like that. So we'll just wait for this to start up. Again, it's got to download the dependencies from Maven. It's also got to download the Docker images. But once it's done that, it will run a lot quicker. So if we just have a look here, sound application, don't worry about that. I just haven't implemented any logging. Don't worry about too much about that. So this should now start up our application, do its tests. Cool. So yeah, so that was just an example of it running with microshed testing. Yeah, so basically, if we do Maven Liberty Dev, this is quite cool as well. So this essentially allows OpenLiberty to run in dev mode, and I'll talk a little bit about that later. But what it does is it enables me to make code changes without having to restart the server. So the server will automatically pick up any code changes that I make, which is quite cool. Basically saves time starting and stopping, waiting for servers to start, waiting for Maven to do its thing. And the code changes happen so quickly that by the time you get back to your browser, the change will have already been made by the time you've managed to refresh the page, which is quite cool. So we'll just wait for this to start up. So our server's ready. So the great thing about this is all you have to do is to run your tests again is just press enter. So it won't run your test every time you make a change, but if you do want to run your test, all you do is hit enter. Again, it's going to go download the name dependencies, run what it needs to do. So this is going to do it with Microservices testing. Like I said, Microservices testing works in the same kind of test phase in Maven that your normal tests do. Cool. So as you can see, yeah, it's all running and it's all good. So I'm just going to press Q to exit, shut down the server and get out of dev mode. And then we're going to go into the start directory to start basically converting a normal test into a Microservices test. So I'm going to run Liberty in dev mode again. So first we need to get and have a look at the class personal service IT. So let's find that. So source, main, Java, person service. It's going to be under test, isn't it? Of course. Person service IT. So pretty basic testing, nothing to do with Microservices testing. And what we're going to do is we're going to essentially turn that into a Microservices test. So let's add in the import Microservices test. Cool. That will then allow us to, as you can see, it's picked up that change automatically, so it's automatically implementing that. Let's go and yep, so we need to annotate the top of the class with @Microservices test. So basically some information about how Microservices test should be implemented. So let me just add in the required dependencies. Yeah, wicked. And then we're going to add in the container. So like I mentioned earlier, the container is kind of what defines, is the container that defines ready for our application to be tested in. And here we've added an extra bit where we're going to define the health endpoint, just so it can do a health check before it starts testing the application. Okay, so we'll save the changes to this. So if we go and run this curl command, you can open up a new terminal up here. So that's basically saying our Microservices is up and it's all good to go. So that's so now we can rerun our tests. Saying that there's nothing in the test, but yeah, we just rerun the test just to make sure everything's still okay. Wicked. Okay. Okay, so now we need something to test again. So we're going to import REST client. As so, and then very simply just put that here. Ooh, got to get the indentation right. Issue there. Okay, so now we've added the REST client here. I'm going to go and save that. So now we need obviously assert equals, so we're going to create our test pretty much now. So we put that in, and then I'm going to add this to the test logic down here. All right, so now we have kind of a basic test here. And as you can see, it knows that it's a test that I'm making changes to. So right, so let's try and run that now. Wicked, so all containers started really quick. Again, the containers will start very quick once it's downloaded. Yeah, that test passed and everything was good. So what we can do is we can add like loads of tests in. So let's replace the whole class with something a bit more useful rather than just this. Hopefully it doesn't break everything in here. The code looks okay. Wicked. Right, let's try and run our tests again. And fingers crossed, nothing fails. Wicked. So now I've got 6 tests and they've all run. So that's how easy it is pretty much to create a Microservices test. So yeah, it's very easy to get going. You can do more and more things. So outside development modes, it tests a bit differently. One thing that it'll do outside development mode is essentially bring up a new container for each test. That kind of replicates it kind of isolates the testing environment. You can turn that off, but by default, that's what it kind of does. So yeah, so that's pretty much Microservices testing. So feel free to give that a go. Now I'm going to talk a little bit about OpenLiberty. So what is OpenLiberty? It's a lightweight open source framework for building Java microservices. Basically, we basically took feedback from all the time we've been developing WebSphere, and we wanted to basically create something that was really, really friendly for developers to actually create code on. And that's kind of where OpenLiberty came around. So we tried to focus on code, make it really easy to write tests, and this is a production environment. It was one of the first Jakarta EE8 application servers to be certified. And it was also one of the first ever IBM products to be containerized, which is cool. And again, we've mentioned dev mode, but what essentially it does is enables you to make code changes very quickly without having to keep bothering to restart and stop the server every time. We are an open source project, so we do have a brilliant website, which many people around in my team and my organization have spent a long time on. There's some brilliant guides here. A lot of the guides that are on the learning environments we're using have come from here. And again, this isn't just focused on IBM specific stuff. You can go through guides to tell you how to deploy to every other cloud provider, or most cloud providers. So I don't know who saw the Jakarta EE developer survey. They essentially made quite a lot of bold statements. I'm more focused on the third one here today, which was basically the popularity of microservices may be waning, with the usage of microservice architecture for implementing Java systems in the cloud declining since last year. So let's think about that for a second. Now, in my mind, no, microservices are not going anywhere, and I think they should definitely still be the default architecture style you choose when creating cloud-native applications. So basically, we've got this concept of macroservices. And I just want to clarify, this is kind of a concept that I quite like this, and a lot of people may disagree. But essentially, you've got your monoliths. But a macroservice is more like a right-sized service. So when you've got highly coupled services, it can be very difficult to break them apart. So people that are trying to go down the modernization route and modernize monoliths, sometimes you can only get to a certain point where you can break things apart anymore without having to do major code changes. So macroservices fit quite well for a lot of people, and it's not just me that sees this. A lot of other people in the industry are talking about similar concepts. So this is kind of where I see Liberty fits in. So you've kind of got on one side, you've got your functions as a service. So you want your application server to come up very quickly, to start very quickly, to do what it needs to do. And on the left-hand side, you've got your monoliths, which would stay up for a very long time. Don't need to be shut down. They could stay up for years without you actually restarting or shutting down the server. So Liberty kind of fits in the middle of all this. So it's brilliant. It pretty much has all the capabilities of WebSphere. It also essentially is really lightweight and small and can start up very quickly. So it spans quite a lot of different use cases and architectural styles. Now, for function as a service, I'd probably pick Quarkus, but this is kind of where I see OpenLiberty and where it fits. So we've been chasing this 1 second startup time for nearly 2 years, and we've pretty much got it down to where it is, and that's basically come with changes in OpenLiberty itself and in the JVM OpenJ9. So this is a comparison of OpenLiberty compared to other Java application servers on Hotspot. But as you can see, if we go to OpenJ9 and use shared class cache, which is a demo I'm going to show you later, you can see that time reduced dramatically. So it's approved for lots of applications. It's not just a certain application we've done this with. We've tried it over loads of different applications. And yeah, so it's even similar in Docker. So what we're going to see today, again, I'm going to test this on this learning environment, and that's all running in containers. And what we should see is OpenLiberty start up generally in about 8 seconds. What we're going to see is hopefully that drop to a much lower amount, hopefully around the 2-second mark. So this is kind of the performance difference of OpenLiberty with EE7 compared to other Java application servers. So better startup time, better memory footprint, and better throughput also. But then if we go, this is specific Acme Air application, so kind of similar kind of stats there. Only Helidon is only 1% faster to start up. But again, memory footprint is quite a lot lower, and we've got a much better throughput. So we've kind of done a modernization technique for Spring Boot applications because we don't like fat jars, so we've had to figure out a way to get around that. So basically what we've done is, essentially this is what you have. So with your Uber jar, you generally have these top layers that are pushed every time, and they're quite hefty. You shouldn't have to do that. So the solution is to kind of break that all apart. So we've used OpenLiberty with OpenJ9 for this, and we've used minification steps to kind of shrink down those layers and created more layers, Docker layer images. So this is kind of what we've done now. So the top layer, which is your application classes, that changes a lot, but that's quite small. You've got the Spring Boot core classes, but they change rarely. So again, you won't have to push them every time you make a change. But then you have the underlying classes, so OpenJ9 and OpenLiberty, which will change very rarely. So by splitting our containers up into these different layers, we can minimize the amount of that gets pushed every time we want to make a change. So the steps we've done to do that, so we minimize the JRE, so we've got that down to 59 megs. You can use Minify and OpenLiberty, which shrinks OpenLiberty dramatically. And then the thin layer of the Spring Boot application on the top, splitting those up, so having the core Spring classes as one, and then your application classes as a separate layer. So if we look at startup time and compare OpenLiberty, yes, Tomcat is slightly faster, and I say slightly. But if you look at memory footprint, OpenLiberty has like nearly 5 times less memory footprint than Tomcat does with Spring applications. And look at throughput. So throughput, OpenLiberty nearly has double the throughput. And when it's only a slight difference in startup time, I believe the other two metrics outweigh that one. So we've also got Crew, which is a very interesting technology. Essentially, it allows you to kind of do hibernate of your application, and that basically means it'll sleep your application in its current state and then start up very quickly. This is a new concept, a new technology. Not a new concept, but this Crew is specifically a new technology, and it's in its very early stages and it has its problems. But as you can see, the startup time is really, really low with this technology, so it definitely has its benefits. So yeah, just a summary. So yeah, OpenJ9 again together with OpenLiberty work really, really well and have really cool, good performance benefits. So now we're going to talk a bit about OpenJ9. So Eclipse Foundation has basically taken over, adopted OpenJDK, which is cool. So why OpenJ9 versus Hotspot? Again, footprint's a lot lower, faster startup time, and it's not just OpenLiberty. This is pretty much anything you run on this JVM, and it's got really good broad platform support, and I think it even has support for ARM architecture now as well. So we've got a lot. The problem is we've got loads of metrics we need to handle and think about on the cloud. So the key kind of metrics we need to think about is startup time, ramp-up time, memory footprint, response time, and CPU throughput. Startup time, obviously, we want it to start up really quickly. Ramp-up time, we want it to get to where it should be to receive max throughput as quick as possible, because if we're not, that's essentially resources and money we're wasting, and energy, like I mentioned before, on the cloud. We want a small memory footprint. It needs to have a very quick response time, especially if we're now using microservices to do everything. And again, we need like high throughput. So yeah, so OpenJ9 has quite a small deployment size, and there's lots of different images depending on what you want to do with it. So yeah, by reducing a lot of these things, we're essentially reducing the amount of money and again the amount of energy we're spending on the cloud. So this is a really cool tweak you can do, which basically, if the JVM is not having any throughput, then what it can do is idle a little bit. So that can save you essentially some money and energy on the cloud. And the JIT server. So what the JIT server does, it's kind of like a load balancer and splits up JVM into like smaller servers. And the great thing about this is then it can handle throughput on constrained environments. So we've got OpenJ9 here and the JIT's OpenJ9 with the JIT server enabled. As you can say, in a 300 meg environment, they pretty much perform the same. But then if we constrain that down to 200 meg, as you can see, OpenJ9 is struggling with its throughput. Whereas the JIT server, yes, it's reduced, but not a crazy amount, not to the point where it's probably going to start, breaking your application or making timeouts happen. So yeah, startup time and ramp-up time, like I mentioned, are really important on the cloud. Again, when we taking forever to do these things, it's costing us money. Being able to scale up and down really quickly should save us money and again energy on the cloud. So yeah, so this is the demo I'm going to show you in a moment, but basically it's a shared class cache. And what this does is essentially allows you to store in a special cache the things you use at startup. So this is brilliant because it basically will make your application startup a lot quicker. You don't have to do anything crazy. All you have to do is, I'll show you, add the argument, do a cold start, which will basically basically populate the cache, and then after that, just run it as normal with this argument on, and you'll notice the performance benefits straight away. So again, what is it? Basically, it's a cache in your JVM, and if you restart your computer, it will stay there. So it's not something that just gets thrown away essentially when you restart your machine. It can't grow in size, but you can make it bigger, and you can set different maximum limits on it. So normally with a JVM, it would go class loader cache, parent, and then the file system. So in contrast, what it does now is class loader cache, parent, then it does shared class cache, and then the file system. Like I mentioned, 32 megabytes in size. To enable this, all you have to do, so with OpenLiberty, I'll show you we have a JVM options file, and all you have to do is have X share classes in it. You can specify a name, you don't have to. That's if you're dealing with different environments you might want to enable it on, etc. But all you need to do is enable that, do a cold start, shut the server down, do it again, and you should see the performance benefits. So again, OpenJ9, this was IBM's Java for a long time, and it's run by a lot of enterprises around the world. It can go small to large. It's really good at constrained environments and memory-rich ones. And basically, it's got really fast startup time and throughput, and that's what we want on the cloud to save money, and something that's a bit more relatable to us developers, energy. So yeah, so let's go in and have a look at me enabling shared class cache on the JVM. Okay. Okie dokie. So what I'm going to quickly do is I'm going to log out of this session, and I'm going to go into nice simple microservice, which would be creating RESTful web services, and then we can enable the class cache on there. So just wait for this. Okay, just to log me out, just so it clears my environment. So if you're following along by logging out of this system, you can log in loads of different ways, and also you can delete your account straight away afterwards if you do want to. But essentially, if you log into here and you log out, it will clear your environment for you. So it'll remove all your directories and things like that. And again, what this does, it goes and pretty much goes and creates you a new container. You can customize the layout, and it will save that to your image for you. But it'll create you a new container on Kubernetes, start it up, which will allow you to then go and essentially start developing quite quickly. And the great thing about this is it gets everyone up and running with the same environment. So one of the pain points I've always had with demos, or people follow along with demos, or basically even workshops, is the prereqs, getting everything sorted. Everyone's configuration environment is different on their own computer. So having this here basically allows everyone to follow along, be at the same stage from the beginning, and actually test out some tech. Okay, so let's go and clone down the repo. And basically what we're going to do is go into, we can just go into the finished directory and then run Liberty. So now we're going to have a look to see how quickly OpenLiberty starts up. And while we do that, I'm going to go into the finished directory, source main Liberty. So essentially in here, we just have a config directory. So this directory kind of gets copied into the application server when it starts up pretty much. So we're going to go and create a new file in here, jvm.options. Cool. And now we're going to just do x share classes. Oh, we need a dash at the front of that. Okay, so what we're going to do, we're going to have a look and see how long it takes OpenLiberty to start up now, and it will tell us at the end. So 9.4 seconds it took OpenLiberty to start up there. Okay, cool. So let's shut that down. We're going to enable this. and then we're going to start up OpenShift again. So again, it's going to do a cold start first, so it needs to populate that cache. But there's nothing you need to do specifically. You just need to give the server or the JVM essentially that variable, that argument. So now we're down to 6. So now the cache is populated. Let's try it one more time. And hopefully the demo gods are kind, and it's actually going to start up OpenLiberty a bit quicker. Do 1.9 seconds. So as you can see, just by doing a simple JVM tweak, we managed to start OpenLiberty up in a quarter of the time they did before. So, and this is not just an OpenLiberty thing. You can try this with all your different Java application servers. It's really easy if you're using Docker and stuff just to swap your base image to use OpenJ9 and basically test it out. So finally, let's talk a little bit about OpenShift. So why should developers care about DevOps? Well, the thing is, if you've got to constantly worry about your DevOps pipeline breaking or this, that, and the other, it can make essentially you as a developer not as productive as you should be. So having a great developer pipeline, it will improve quality because you'll get feedback on your code a lot quicker. You'll get stuff into production quicker, which means customers can get their hands on it and use it quicker. And it improves communication and collaboration. So rather than just throwing something over the wall and just hoping it works, being able to get feedback on code, running in specific test environments, yeah, it's really cool. So these are some of the reasons why developers should care about DevOps. What is OpenShift? It's a Kubernetes-based platform with added functions. It kind of streamlines the DevOps process by basically adding things into your IDE and adding things on top of Kubernetes like a really nice GUI, enable you to really visualize what's going on. So again, really great IDE integration. So as a developer, you don't even, if you've got Eclipse JBoss and lots of other IDEs, you don't even have to leave your IDE to do anything. And as I said, in the future, I can see that becoming a thing on through a browser. So it's really great that we have all this really nice integration between all these different things. So I just want to talk a little bit about IBM's differentiation and its investment in all stacks. So IBM does like to try and invest in all parts of the stack now, and this has basically added really good performance benefits going forward. So at the hardware level, we have influence over the bottom level, the operating systems, all the way up to container orchestration with OpenShift, OpenJ9 as a JVM, and then OpenLiberty on the top. And like I mentioned, having influence over all the parts of the stack, not control, but influence, has led to software and hardware improvements over the years. Now, I'm not saying you need to take every part of this stack, but just try out bits of it and then try a couple of them together and then kind of see some of the benefits and basically just try and have a look at all the different parts of this open source stack and kind of weigh up what makes sense for you to use and what would actually benefit you and your organization. And the other good thing about OpenShift is we kind of run on the hybrid model. So we want OpenShift to run everywhere. A lot of people at the moment, they're moving stuff to the cloud and they're probably creating new workloads on the cloud. But then most organizations don't want to move everything, and some will never move everything. But having, a DevOps pipeline and a Kubernetes kind of orchestrator locally in your local development environment, your local data center, and having the same thing on every cloud you use, basically will just streamline the process of you getting stuff up and running into production, no matter where you are running this. So quick recap, MicroProfile, no vendor lock-in, loads of APIs, and the community is getting bigger and bigger every year, which is great. OpenLiberty, nice modular application server, so it starts very small and you add the features that you need. Really easy to configure. We were one of the first application servers to be Jakarta EE certified, production ready, and again, we've had official Docker images for ages now. OpenJ9, low memory footprint, really fast startup time, which is good for saving money and energy in the cloud. Great throughput, really good ramp up time. So again, we want our JVMs to ramp up like that very quickly, not do that to get to where it should be. And again, loads and loads of Docker images for OpenJ9. And OpenShift is great because it works on all clouds, which is wicked. So it works on the IBM Cloud, Azure, Google Cloud, as long as they've got Kubernetes, which is pretty much everyone. It uses containers, so it's really easy to port things around. So again, like I said, it's very easy to port something that could run in your local data center and then move that onto the cloud. And again, like I said, it runs on private and public clouds. So yeah, and I just kind of want to just mention that all this is open source software, and think that trying to achieve the things you can with this software 10 years ago, 20 years ago, 30 years ago, just wasn't possible. So yeah, please take a look at some of this tech. It doesn't have to be the whole stack. Just have a look at little parts of it, and just try it out, see what you think. And again, it's all open source and it's all free to use. So I hope you all enjoyed my talk. Any questions, just message me on Twitter or talk to me in the chat channel for J4k. Cool. So thank you all.